Welcome to aminacademy.com. In expansion in Fourier series of the function, let us do some solving problem. Look at this example. Expand Fourier series of periodicity of 2 pi for f of x equal to x sin x for 0 lesser equal to x lesser 2 pi. Here we have to find the coefficients, Fourier coefficients. First, a0. A0 equal, here 2 pi is periodicity, therefore here 1 over pi integral c to c plus 2 pi f of x dx. Here 1 by pi integral c0, because this limit is 0, and 2 pi x sin x. F of x is x sin x given. Now we are integrating x sin x. 1 by pi integral of x sin x is product rule. First function, integral of sin x is minus cos x minus integral of differential of x is 1 and integral of differential of first. So minus integral of differential of first is then minus sin x. Zero to 2 pi. Here simplifying 1 by pi. That means you are giving the limits 2 pi and 0. We have, which gives minus 2 pi cos 2 pi plus sin 2 pi. Which gives cos 2 pi equal to 1, that is minus 2 pi, 1 by pi minus 2 pi, because cos 2 pi is 1, plus sin 2 pi is 0, which is equal, that is a0 equal minus 2. First coefficient a0 we got it. Second one, an equal 1 by pi integral c to c plus 2 pi f of x into cos nx dx, which equal, that is 1 over pi c0, therefore 0 to 2 pi, because c0, and x sin x, because f of x is x sin x, into cos nx dx, which is equal 1 by pi we are integrating x sin x cos nx. It is little lengthier. We will do the things first function, and that is before integration, which is equal expanding 1 by 2 pi integral 0 to 2 pi x into sin n plus 1 x minus sin n minus 1 x. That means here sin x into cos nx, product of sin x and cos nx is adding subtraction of sin of n plus 1x minus sin of n minus 1x. Product become subtraction here. Additional subtraction, which is equal further 1 by 2 pi. Now we are integrating this separate first function integral of second, like here, which is equal x minus cos of sin n plus 1 x integration is sub n plus 1 x over n plus 1 minus 1 into integral of differential of first, integral of second, that is minus sin n plus 1 x over n plus 1 the square, because one more time integration. Then for this function seem like sin n minus 1 x into x, which is equal, further it is minus x into minus cos n minus 1 x over n minus 1 minus 1 into minus sin n minus 1 x over n minus 1 the square, 0 to 2 pi. We are applying this 0 to 2 pi, this now it becomes, after applying this 0 to 2 pi and simplifying, we get 1 over 2 pi minus 2 pi over n plus 1 minus 1 into 0 minus 2 pi over n minus 1 minus 1 into 0. For the simplification, we give 1 by 2 pi, then 2 pi will cut, both 2 pi will cut, then it's simplified as minus 1 over n plus 1 plus, we have minus minus plus here, and 1 over n minus 1, which is further equal, that is equal 1 over n square minus 1, because n plus 1 n minus 1 is n square minus 1. Therefore an is 1 over n square minus 1, provided n is not equal to 1. From that we can write a1 equal a1 equal to 1 over pi integral 0 to 2 pi x x sin x cos x x sin x into cos x dx, which is equal 1 by 2 pi. That is, we are splitting sin x into cos x is addition of subtraction of sin and cos. So we have 1 by 2 pi, then which is equal 1 by 2 pi integral 0 to 2 pi x sin 2x x sin 2x. That means sin x into cos x is sin 2x. So we simplified like then, which is further equal 1 by 2 pi, then integrating, that is x first function integral of second minus cos 2x by 2 minus 1 into minus sin 2x over 4, because we get sin 2x and 2 into 2 is 4 here, then 0 to 2 pi. 0 to 2 pi we are applying, we give a1 equal 0 to 2 pi, we are applying this a1 equal to minus half. Then we are getting bn. Coefficient bn is 1 by pi integral x sin x into sin nx dx, which is equal 1 by pi, because we are using product rule, that is sin x into sin nx as subtraction of sin and cos, that is 1 by 2 pi 0 to 2 pi x cos n minus 1x minus cos n plus 1x dx. So which gives 1 over 2 pi, that is x into integral of this product rule here, which is x into sin n minus 1x over n minus 1 minus 1 into minus cos n minus 1x over n minus 1 the square minus x into sin n plus 1 n plus 1x over n plus 1. That is, we are using product rule here. minus 1 into minus cos n plus 1 x over n plus 1 whole square, fully 0 to 2 pi. After giving the limits and simplifying, we will get which is equal 1 by 2 pi minus 1 n plus 1 square minus 1 n plus 1 the square minus 1 minus n minus 1 the square plus minus 1 n plus 1 the square, or common 1 over 2 pi. Then simplifying further, we get bn equal to 0. After substituting this, after simplifying, we get bn equal to 0 provided n is not equal to 1. bn we got. Then further, therefore bn equal to 0, b1 equal to 1 by pi integral x sin x into sin x dx, then which is equal 1 by pi integral 0 to 2 pi 0 to integral 0 to 2 pi x sin squared x dx is equal 1 by pi integral 0 to 2 pi x into sin squared x is 1 minus cos 2x over 2. Then square become normal here. That is sin squared x is 1 minus cos 2x by 2 and dx. Further integrating, now which is equal to take out, that is 1 by 2 pi, that is integrating, we have one integration is x minus sin 2x cos 2x is sin 2x by 2 minus 1 x squared by 2, x integration is x by 2 plus cos 2x integration is plus, that is minus some minus become plus cos 2x by 4. That means you are using uv function here 0 to 2 pi. Then which equal, we are substituting 2 pi 0 to 2 pi limits, we'll have finally we have 1 by pi to pi square, which is equal pi. Therefore, b1 equal to pi. Now applying the Fourier series expansion of the function x sin x equal, we can write it. Therefore, f of x, which is equal x sin x is equal 1. That is, you are substituting all coefficients. That is a0 by 2. Right, first a0 by 2 is 1, then minus half cos x. We'll write this function first. That is a0 by 2 plus sigma n equal to 1 to infinity. That is an cos nx plus bn sin nx. So after simplifying, we get f of x equal 1 minus, we are substituting the values an, bn, a0 by 2 by 1 minus half cos x plus 2 into sigma 1 to infinity sigma n equal to 1 to infinity. We have cos nx over n square minus 1 plus pi sin x. Such a big problem we have done. Please subscribe our YouTube channel. That is here f of x. F of x equal to x sin x. We expanded as a Fourier series. We have done. Please subscribe our YouTube channel.